Hello and welcome to today's webinar presented by Delubal Software. Today we'll be working in our structural analysis and design software, RFEM. The topic for today's presentation is construction stages analysis in RFEM 6. My name is Amy Heilig. I'll be your presenter. I'm the CEO of the US office and also a technical support and sales engineer, and I'm located in Philadelphia, Pennsylvania. My colleagues Alex Bacon and Siska Choa will be your moderators, answering any questions you may have. They are both technical support engineers, also located in our Philadelphia office. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within this same dialog box. If by chance we don't get to all your questions, we'll certainly send you a follow-up email afterwards. So regarding the content over the next hour today, I first want to give a brief introduction to our new construction stages analysis add-on that's available in our new program RFEM 6, and just in general why we would want to consider stage construction. We'll then move on to our example where we will be defining the construction stage definition from the modeling point of view, so where we deactivate elements, activate additional elements, and so on. We then want to move on to the construction stage definition from the loading point of view. So how can we combine these stages with our load cases, load combinations, and design situations? We will be incorporating the construction stages with the additional design add-ons available in RFEM, and specifically for today, we'll be looking at the concrete design add-on and the steel design add-on. And of course, throughout our example, we'll be taking a look at the analysis and results. So we might be wondering, why would we want to consider stage construction? Well, we know during the construction process that the structure may actually pass through several loading conditions that vary from the completed structure. So for example, when we're talking about multi-level story buildings and adding each additional level on top of each other, well, the previous level is already undergoing deflections and stresses. So for example, if we look at the building over on the right-hand side, we set up our formwork for the first level, we let the concrete cure, we remove the formwork and we move on to the second level. That first level is already undergoing, again, some of these deflection stresses from self-weight alone, or maybe some of those additional construction loads. So we'd like to take those into account with stage construction. Now, regular simple structures may see very little difference when we compare the stage construction to simply applying the loads to the finished structure. However, when we're talking again, maybe with those multi-story buildings or structures with vertical irregularities, such as interrupted columns or walls, we might actually see a significant result difference between the finished structure versus taking into account each continuous stage. The construction stage analysis add-on within RFEM allows us to compare similar structures under different modeling or loading scenarios in a single file. And we also can include nonlinearities with these comparisons. So rather than creating multiple files with the first level completed, then the first level and the second level completed, we can consider all of that in a single model. Now, we also have the ability to run the design checks according to the various codes for each of these stages by incorporating them, again, with those additional design add-ons. I'd already mentioned the concrete and steel add-on, but we also have the aluminum design, timber design, and even some of these niche markets such as fabric tensile structures. So with our form finding design add-on, this can be integrated with those construction stages as well as stability design and so on. So let us begin in RFEM today. So this is our main FEA program. You can see that I've taken the liberty to go ahead and model this two-level story structure here, all concrete elements. So I'm going to visit my base data dialog box by right-clicking on the model name here. within the navigator to access the base data. Now, this is the same dialog box that would be initially pop up when you create a new model as well. So under this second tab, this is where we have all of these optional add-ons. And this would allow you to essentially purchase these add-ons specific to your materials and your design that you're doing for your particular projects. For today, we're going to be working with the construction stages analysis add-on. You can see that's turned on here, as well as the concrete and steel design add-ons located over here on the right. So now under the third tab, this is where we set our standards. So we want to generate the load combinations according to the ASCE 7, which is available within this dropdown. We'll see here the NBC standard, as well as Eurocode and many other international standards. As far as the concrete design, we will be using the ACI 318, and steel design will be the AISC 360. Now, of course, again, using this dropdown, we can see the CSA standards available to us, as well as the other international standards. So once we have verified this information under the base data, we'll go back here to review some of the elements that have already been modeled. So if we take a look again at the navigator, we'll see that all of our elements were utilizing 4,000 PSI concrete. Looking at our cross section, so all of my columns here, if I double click on one of them, are going to be utilizing this 11-inch by 11-inch square section. Under the second tab, we can see that the concrete material here is set to 4,000 PSI. Now, back under the main tab, notice that the design properties is checked on here. And this just simply means that we not only want to use this member for the analysis within the main program RFEM, but we're also going to do the design utilizing that concrete design add-on that we had turned on within our base data. So this just gives us all of the available tabs up here to define our reinforcement that will, of course, be used later on within the strength and serviceability design. Now, I'm not going to go into too much detail today. There is an additional webinar that's devoted entirely to concrete design according to the ACI that's available on our website and YouTube channel. So just to quickly cover this, we'll see here that we can specify the concrete cover. For the shear reinforcement, I have defined number 3s here at 12 inches on center. And then I also have my longitudinal reinforcement, which is going to be 12 number 6s spaced evenly around our cross section. So this is a very similar workflow here for my surfaces as well. Each of these surfaces was defined here with a thickness of 12 inches. So if I double click on one of these surfaces, again, we can see that thickness defined here, 12 inches with the 4,000 PSI concrete. Again, I've activated this design property. So we're not only using it for the analysis, but we also want to define our reinforcement for this slab to do the design later on within the concrete design add-on. We see here the concrete cover is defined as well as the surface reinforcement. So looking at this surface reinforcement, we can go into the details here. I have specified just simply number 6s at 6 inches on center in both directions for both the top and the bottom. So very simple application for this concrete slab. But I also have all of these additional free rectangular reinforcements defined. This just allows me to place some additional reinforcement. You can see number 6s again at 6 inches, where these concrete columns are framing into this slab. So rather than applying to the entire surface, we apply to what we call this free rectangular location. So once we have defined all of our reinforcement here, what is actually turned on by default, if we go to our Views tab within our navigator, up here under the Types for Concrete Design, and maybe I turn this into wireframe view, we can actually see the reinforcement here displayed graphically. So we see our shear and longitudinal reinforcement for our concrete columns. And then, as I mentioned, those slab elements, we have our number 6s at 6 inches on center, but we also have some additional reinforcement here where those columns are framing into the slab. So we can always turn off this display just to get a little bit of a cleaner look here. Now, additionally, what else I have hidden, which I will turn on now, is the mesh refinements. So I've added these FE mesh refinements, you can see by these symbols here at the tops of each of the columns. So we know that within the program, we're likely going to get what we call singularities, where these single line elements, which are essentially our members here, frame into these slab elements at the single FE mesh point. So I'd like to refine the FE mesh here, which you can see I have went ahead and done with a nodal mesh refinement. Additionally, what I have defined, which we'll find it here under the result objects, is what we call surface result adjustments. So now we can see all of those displayed here at the tops of our columns. And if I double click on one of these, what we can see here is we have the ability to actually average out the internal forces over a set area. Again, this just helps smooth out those singularity areas. For my simple example today, I actually just zeroed out those internal forces at those locations. They're not really a concern for our simple example today, so I went ahead and set that as the definition type here for these surface result adjustments. Again, all of this is just to help with those singularity issues. So we'll go ahead and turn those off. These will come into play a little bit later on, but for now, we will turn this back into the rendered view. So this is my starting structure, just simple two-level concrete elements. And ultimately what I'd like to do is to remove these center two columns here on the first floor. And instead of these center two columns of this existing structure, I'm going to actually add in some steel beams that span between these exterior columns underneath the slab, as well as an additional couple of steel columns that are slightly offset from the center of the structure. So we're going to deactivate these columns and instead add in some steel members, which will just describe the workflow here of our staged analysis. So before we define any of these construction stages, we need to ensure that we have everything completely modeled in RFEM. So we will begin by drawing a new member here, and up in my quick toolbar, I can draw a new single member. Now, under the section tab, I want to define a new cross-section by visiting my cross-section library, and we can see all of the various sections we have available to us, including the parametric sections, where we just simply input in the dimensions and the cross-section properties are calculated automatically. Now, alternatively, we can view these standardized sections. For example, we can activate here our I-beams. We can use our filters on the left to filter to the United States and to the AISC 15, and I want my beam section to be a W14 by 82. So I scroll down here to my list, I select the 14 by 82. Of course, we don't want this to be a concrete material, so what we'd want to do then is to activate our material library for this particular section. Once we launch our material library, again, we can use our filters on the left to filter to the material type steel, and then we can set the standard to the AISC 360, and we'll see here steel A992. Now for me, I already have this steel material defined within this model. So rather than redefining a new material every time, I now can just select it here within my dropdown. So I can select material number 2, A992, and our beam has now been defined here with the correct cross-section as well as the material properties. So in addition to defining the cross-section and material, notice that the design properties is turned on here as well, but we're no longer referencing the concrete design add-on that we activated under the base data, but we're now referencing the steel design add-on. Before I draw these members, I also want to activate here a couple other options, including hinges and eccentricities. So notice we have two additional tabs here up at the top. Remember that everything within RFEM is considered fully fixed. So if we want to release a moment, for example, at the ends of the member, we do need to define a new member hinge. So we do so by activating the hinges, we create this new definition type, And the program is automatically going to assume that I'd like to release the moments based on the local Y and local Z axes of the member. So this is a member end moment release here. I click OK. Now I've applied that to the member start. Rather than redefining for the member end, I can now simply select it here from my dropdown. So we'll go ahead and release the moment at either ends of this particular section. Now the eccentricities is a very similar workflow. We want to define a new member eccentricity here. And I'm going to use this option within my dropdown relative to section. And I will tell the program to take the topmost point of my cross section, and I actually want to offset it from an additional object that already exists within my model. And I'm going to select here the option surface, and then I can graphically select surface number 1. And I want to drop this beam member down below the bottommost point here of this surface. So the whole advantage here of using this option relative to section is that if I make any changes to my cross section size, or I make any changes to the thickness of my surface, well, this eccentricity will automatically update. I don't have to come back in here and adjust it manually. So we applied that eccentricity definition to the member start. We also want to apply it to the member end. So now that we have defined the hinges and eccentricities, I click OK, and then I will snap from the right-hand column to the left-hand column at the front of the structure, and also do the same at the back of the structure. So now we can see this steel column drop down below the surface. Obviously, it's intersecting these concrete columns, but that's completely fine. We'll make these changes later on with the construction stages so that both of these do not exist together. I'm going to hold down my control key and select both of these members. And I want to right click here, and under the member option, I'm going to divide the member by a set distance. So here is where I want to add a node along the member 8 feet from the member end. But instead of actually dividing the member, I'm going to turn on this checkbox here to create the node along the length of the member without dividing it. So when I click OK and we turn this into wireframe view, you'll see that this is still one continuous member, but we now have a couple of nodes here defined along the member length. And these nodes are special in the sense that they're of the type on member, and the program automatically detects which member it should be integrated with. So what this allows me to do now is to draw in my steel columns that will frame into these steel beams. So I'll begin here by just adjusting my drawing work grid, and we can turn this on at the bottom of the page here, and we will also adjust the plane. And I will create a new cross section yet again. So the member type is set to beam. The section here will be defined once again from my section library. In these standardized sections, I want to select here a W8 by 35. Remember, I already have my A992 material defined within the model, so I can select that here. I click OK. And the one thing that we'd like to add here is also a hinge definition. So under my hinge tabs, remember I have already defined that moment release, so I can select it here from my dropdown as well, where I can release the moment at the member end. I click OK, and then I'm going to snap from the bottom of the structure up to that node that was created. I can right click to exit this dialog box. If we take this element, we can highlight it, hold down our control key, and we can drag and drop to the rear of the structure to create that additional column. So now that these two columns have been generated, there's a few additional things that we want to take into consideration. Number one is we obviously need to add some supports to the bottom here. So we'll go ahead and add in a new nodal support. We're just going to use one of the default definition types here, hinged. I can click at the bottom of these steel columns to add in that nodal support. The second topic is holding down my control key to select both of these columns. So remember, we are going to design these members utilizing the Steel Design add-on at the end of this example. But one thing that is required if we want to do so is we do need to define information like the unbraced lengths. And we do so here under the design types effective lengths. Now, again, I have an additional webinar devoted entirely to steel design according to the AISC that goes into much more detail to talk about the unbraced lengths or effective lengths definition type here. So we'll just quickly add in these intermediate supports that are going to be applied here for flexural buckling, torsional buckling, and lateral torsional buckling. And under this second tab, the default options is to add in this intermediate support at the member start and member end. And now my unbraced lengths for my stability design will default to the full member length. So when I click OK, you can now see that we go back into the model and the unbraced lengths have now been defined here for these particular elements. Now we need to do the exact same thing here for our beam elements. So we'll go ahead and select both of these elements, and under the design types here, we define a new effective length. But this time, the slight difference is I want the program to go ahead and detect here these intermediate nodes, and in particular where this steel column frames up into this steel beam, where I can add an intermediate support in the vertical direction here. So now the program will consider this with the effective lengths or the unbraced lengths for our stability design. Okay, so that takes care of the unbraced lengths, which will again come into play a little bit later on for our actual steel design according to the AISC. The final topic here related to this first story is currently this slab element is entirely connected to this steel beam. So full first transmission, full moment transition between these two elements. Now, if we would like to release some of those degrees of freedom, what we can do is to consider what we call a new line hinge. So under the option here, types for lines, we expand this folder and we see here a line hinge where we can right click to create a new definition type. So with this line hinge, I'm actually going to release all degrees of freedom. So we have 3 in translation based on the local X, Y, and Z axes, and 1 in rotation. Now keep in mind that these are based on the local axes of the line element itself. So not the local axes of the surface or of the member, but of the actual line. Each line has its own X, Y, and Z axes. But rather than obviously keeping these as fully released, we do want to add in here a nonlinearity. And this nonlinearity will allow the slab to bear down on the beam when we have this downward deflection. So if we have a negative shear value in the local Z direction, then we should see full fixity. But if we have uplift, then that relationship between the slab and the beam will be released. So again, applying this nonlinear behavior here to this line hinge. So once we have the definition type presented here, we want to actually apply it to the model. And we do so by first selecting the surface that we want to apply the line hinge to. Then we will select the lines where we can select the front line number 12 concurrently with the back line here, number 18. And we click OK, we click OK. We can zoom in here and what we will see is a very small symbol for that line hinge definition. Again, this will also come into play with our construction stages. So we're now complete with this first story. The final thing that I want to do with this model is to actually add in a third story, a partial third story. So we want to do that, but before we do, if you remember, I'm going to go back to the nodal mesh refinements. I'm going to turn back on my concrete reinforcement and also those surface result adjustments. And I'm doing so because when they're graphically displayed here, this will ensure that when I copy all of these elements to the third story, all of these details are also copied. So we can go ahead and highlight this top story here, including the reinforcements, mesh refinements, and so on. Now, normally we could use this simple drag and drop copy that I showed you with my seal columns, but I want to take advantage here of the Move Copy tool for a specific reason. So we're going to create a copy here of that second story, and I can either type in my displacement vector or we can use this measurement tool. So I can kind of snap here to the bottom of that second story to the top, and we see the program automatically detects this is 11 feet in the Z direction. But under the numbering and options, I have the ability here to not only copy all of the elements, but also the loading. So I have some existing loading on the structure for dead load and live load, which we'll visit in just a few minutes. But by activating here this checkbox, all of those loads will also be copied. So I click OK. And what we should see here then is the addition of this third story. Now for this third story, I actually want it to only be a partial third story. So we'll need to clean this up just slightly, and I can do so by holding down my control key to select the top of these nodes of these columns. I hit delete on my keyboard, and now all of those columns are gone. I'm also going to hold down my control key to select my columns as well as the nodal point here at the tops of the columns. And I'm going to use my Move Copy tool once again, but instead of creating a copy here, we'll go ahead and uncheck this. I want to use my displacement vector. I will select from the left-hand side of the structure because I want to move those columns right here to the center of the structure. So displacement vector of 13 feet. So now when I click OK, what we should see here is that partial third story. Now, notice that all of my reinforcement was copied as well, and it's somewhat adjusted here as I essentially shrunk down this third story to partial third story rather than the entire area here. So back under my navigator, we can see here the types for concrete design and all of my surface reinforcement listed. So the program was intelligent enough here to go ahead and apply the same reinforcement to that third story. And we see our number 6 is at 6 inches on center. We also see our free reinforcement here, free rectangular reinforcement that was defined for that third story. So we can make modifications here if maybe we're not needing such close spacing, or we want to make modifications to our bar diameter, we can do so. But for this example, I'll leave everything as we see here. So all of this information over here that exists, we can simply highlight it and hit delete on our keyboard. So essentially the modeling is now complete for this structure. Again, before we define those construction stages, we need to ensure that everything is fully modeled within RFEM itself. So I want to go ahead here and turn off the nodal mesh refinements. I'll turn off my reinforcement and those surface result adjustments just for a cleaner look. So now we're finally ready to begin with our construction stage definition. So back in my navigator, we have a nice feature here. If I right click, I can actually collapse all of these folders. And actually, there's one more thing that I wanted to do that I had forgot before we define our construction stages is maybe we wanted to apply a quick rib element here that spans between these columns. Just to go ahead and introduce you to this rib type, we can draw in a new single member. And we can see here the member type would actually be set to rib. Now, what's special about a rib is we can integrate it with the slab. So those internal forces will now include the internal forces from the slab for some effective width that we define. We also can turn on the design properties to design this as a T-beam, including the reinforcement in the concrete design add-on. For today, I'm not so interested in designing it. So what I can do is just to simply turn this off. I only want to consider it for the analysis. Notice all my tabs here are now gone to define my reinforcement. So under the section, we will create a new cross-section type for the last time, and we'll choose this massive rectangular section, where I can quickly choose under the second tab my dimensions, and I will type in directly 8 by 12 inches for this rib element. 4,000 PSI concrete is already defined, and under this second tab, we want to drop this down below the negative Z direction here of the surface element itself. So when we click OK, we can actually draw in this rib element from right to left. So again, internally, we are including the effective width here of this element. If we revisit the rib section, we can actually see that drawn here graphically. Okay, so now we are done with all of the modeling within the RFEM program here. So we can move on to the construction stages. So we've collapsed all of these folders here. I just wanted to make this a little bit more visible. You'll see here the construction stages option. Now this is only available because again, we activated that construction stages analysis add-on under our base data. So we will start here by right-clicking to create a new construction stage. And you can see the program defaults construction stage number 1. It gives it the name of start. We can override that name if we'd like, but we need to tell the program which elements are active for this first stage. So we'll begin with our members, our surfaces, as well as our nodal supports. And we get additional tabs up here. I did want to point out, you'll notice this option over here that's grayed out for the time-dependent analysis. This is still in development. Eventually, we will link the construction stages analysis to our additional add-on for time-dependent analysis to take into consideration topics like creep and shrinkage. But for now, this is still in development. So under these additional tabs then, what we would like to do here is to add in the initial elements for that first stage, and we begin with our concrete columns. So down here at this first level, I'm going to select all of my concrete columns, and notice I'm making sure that I'm not selecting here any of these steel elements yet. And for my second floor, I select all of my concrete columns here as well. I click OK. My surfaces, well, I want to activate here surface number 1 and surface number 2, and I click OK. And finally, for my nodal supports, I want to activate here the nodal supports at the base of these concrete columns. Again, I am not selecting the nodal supports here of my steel elements, and I click OK. So my first stage definition is complete. I'd like to create my second stage definition here, and I can do so within the lower left corner, number 2. And then you can see here that I again have the ability to override the name. So if I'd like to rename this one, we can call this one Add Steel Members. I want to activate here my members. I'm actually not making any changes to my surfaces. So we can leave this active, but for simplicity, we can also turn it off since we're making no changes. We can go ahead and select the nodal supports. And remember, we also added in those nonlinear line hinges. So we want to activate this here as well. So now under the members, this is where we want to deactivate those center concrete columns. So I select here graphically members number 9 and 13. Now at the same time, I'm going to activate here all of my steel members. So I can graphically select all 4 of these steel members, And now this entire process is going to be completed here within this second construction stage. Now, by all means, we could have certainly separated out these options into two stages. Perhaps we'd like to deactivate our concrete columns first in one stage and then an additional stage to add in the steel beams. It all just depends on how your construction stage workflow is for your particular project. But for me, I just define these all in one stage, so that will happen simultaneously. Now the nodal supports, we do need to add in the pin nodal supports at the base of the steel columns. So we go ahead and select those. I don't need to worry about deactivating here the supports at the bottom of the concrete columns. And in fact, the program won't even let me because it says, well, these members no longer exist. So those supports are no longer active either. Now, finally, we also have the line hinges. So I can graphically select the line hinges, or alternatively, I can just simply hit this all checkbox. We only have one line hinge definition in the entire model, so this option all will go ahead and activate all line hinges here. And this will complete our second construction stage. Now, the final stage, which we again go down here to the lower left corner, and we want to rename this one to add third story. The options here to activate, we want to leave on the members. We also want to activate the surfaces, but everything else can be unchecked. For our members, we want to, of course, add in all of our concrete columns and even that rib element here at that third story. I click OK, and then my surfaces, I could either type in directly surface number 3, or I can graphically select it here. And this will sum up my construction stage definitions. So once I am done defining all 3 of these stages, I can click OK. And what you'll actually see here at our dropdown is each of these construction stages presented to us where we can graphically see what's going on. So here's stage number 1. Here is stage number 2. Notice those 2 concrete columns are gone. We've added in our steel elements. And finally, we have the addition of the third story. So this will sum up the construction stage definition from the modeling point of view. But now we need to move on to the loading. How can we integrate the load cases as well as combinations to these various construction stages? So I want to point out first that I have already applied 2 very simple load cases to our model today. If I activate here my dead load and I turn on the display of these loads, just simple surface loads apply to all 3 levels. And remember, when we copied this third level, the loads were also copied. So just a simple 35 pounds per square foot for our dead load. Same concept for our live loads, slightly different magnitude here of 40 pounds per square foot applied at each level. Now, of course, for a project in real life, we'd probably want to add in wind loads, snow loads, whatever else it may be. But for this simple example, we only have these dead and live loads. So I'm going to access my load cases and combinations dialog box, and we see here these 2 load cases listed. Dead load, which notice self-weight is automatically turned on here with the action category set to dead load directly from the ASCE 7. The second load case is live load, again with the action category set to live. So if we want to back this up just a step, remember under the base data, which we had modified at the beginning of this example, I told the program I want to generate my load combinations automatically according to the ASCE 7. Of course, we can make changes here within this dialog box if we wanted to change to the NBC or any other standard. But when this option is turned on here to generate the load combinations automatically utilizing this combination wizard, then again, the program will reference the selected standard here to automatically create those load combinations. So let us take a look at the design situations. Now, the design situations are absolutely needed when we want to do design in the various add-ons. So we have activated the concrete design add-on and the steel design add-on, and we'll see a little bit later on why we need these design situations. The design situations essentially encompass all of our load combinations. So we have two of them here. We have our LRFD design situations from the ASCE 7. This is going to be all of our factored load combinations, again, directly from the standard. And we have a second design situation for ASD, or this is going to be our unfactored load combinations. And again, we can just reference here to see exactly what they look like according to the standard. Now, if we take a look at the load combinations tab, here are my individual load combinations strictly for those dead and live loads, since I don't have any additional load cases defined. And I have two factored load combinations that again belong to that LRFD design situation shown here in orange. And I have two unfactored load combinations that belong to my ASD design situation. Now, if I was applying the conventional method here of applying all of these dead loads and live loads to my structure, again, on the finished structure with the third story and the steel members, then we would just go ahead and move on with the calculation utilizing these load combinations. But currently, they are not referencing those various construction stages. So what we want to do here is to go to the construction stages tab. And here we see our three stages that we have already defined, which are automatically brought into this dialog box. Now notice that each one of these stages will go ahead and reference the previous stage. So it says continue at construction stage number 1 for number 2. And then of course, if we look at our third stage, it's referencing number 2. A couple other options to point out here. The construction stage analysis is done according to the load combinations. This is grayed out. The reason why is because this is also in development that in the future we plan to add in the option for load cases and a result combination using linear superposition. So this would be for linear structures where we don't necessarily have to incorporate the construction stages into each load combination, but rather we superimpose the results on the finished structure utilizing a result combination instead. So this could be a really powerful increased performance for multi-level story structures. Maybe we have hundreds of load combinations, so this will essentially be very efficient. But for now, it's still in development, so that's why this option is grayed out. Now, the static analysis setting, this is really important. You can see here that my construction stages right now are set to second order. If I go into the detail settings here, we could change this to first order, second order, or third order. We want to ensure that the static analysis settings are either equal to or higher than what we're using in our load combinations and our design situation. So my design situation is set here also to second order, which means that my load combinations will be run according to second order. The problem is that if we set the static analysis order type here to first order for my construction stages, yet but my design situations are utilizing second order, the program will actually give you an error, the load combinations won't be generated correctly. So we need to ensure that we're using at least the same order of magnitude here for my static analysis. Again, we could essentially run third order if we'd like for our construction stages, and design situations could be second order, but I think for this situation it makes the most sense to run them both according to second order. So we also have this second tab here for load cases. We need to tell the program for each construction stage which loads we want to consider. Well, we obviously want to consider the dead load for this first stage. And we can see here when we move it over, the permanent checkbox is by default turned on. So this is going to be a permanent load. Now, I'd also like to consider the live load for my first stage, but I have my permanent checkbox turned off here because that live load may be variable. Well, under my second stage here, and I'm going to go ahead and use my filter down at the bottom to look only at the current construction stage, notice that the dead load is automatically brought over here. And this is simply because we have activated this permanent checkbox. This will always be used as the initial condition then for the next construction stage. If that permanent checkbox is turned off, then we are not necessarily considering it with the initial state. So let's say, for example, remember construction stage 2 is where we've deactivated the center concrete columns and we added in all of our steel members. And for my particular example today, maybe I've removed all of those live loads during this construction process. I really only want to consider the dead load. So we can leave the live load over here on the left where we will not consider it for this particular construction stage. And finally, we have our third construction stage where we've added in that third story and dead load is already automatically included. It has to be because of that permanent checkbox here, but I'm going to factor back in my live load here. So now we have allocated each one of these load cases to the construction stage. The final thing to do here is to tell the program to create the combinations utilizing the construction stages as well as the combination wizard. So I turn on this checkbox here and I go into the detail settings and I'm going to tell the program, don't consider the normal load combinations that we previously saw. Rather, just consider the construction stages only. I'm not concerned with the final structure and applying those loads with the conventional method. And I click OK. And then we can just simply turn on this checkbox here for the rest of these stages. This checkbox is already turned on if we go into the detail settings because it's part of this combination wizard definition type number 1 here. So now that we have selected this checkbox, we should see slightly different load combinations shown under this last tab, and sure enough, we do. Notice that we have our factored load combinations, part of that first design situation, but they are now considering the construction stages. So for stage number 1, we have 1.4 dead load. For combination number 2, still construction stage number 1, we are now also considering the live load, so dead load plus the live load. If I look at construction stage number 2, I'm only considering the dead load, so 1.4 dead. Remember, live load I did not incorporate into this particular stage. But notice that over here on the right-hand side, the program says, okay, well, for the initial state, I'm going to consider the previous construction stage. You can see our load combination number 1. So it will take into consideration those strains, those stresses that the structure is already undergoing from construction stage number 1 and apply this to construction stage number 2 for this particular load combination. Same exact concept here for construction stage number 3. We can see the initial state is set here, but we're also factoring back in our live load. So we see 2 additional load combinations here. Same exact concept for my unfactored load combinations that are a part of this second design situation here, my ASD design situation. Now we see a couple of grayed out load cases down here at the bottom, and we might be wondering what are those for? And they're not a part of any design situation. We might call these ones our auxiliary load combinations, that the program internally creates these load combinations because it needs to solve this as an initial state for some of these load combinations listed above here. So for example, we can see here this auxiliary load combination is used in load combination number 5. So it just depends on what your particular situation is, but if you see these grayed out load combinations, internally the program is using them, but they will not be part of our analysis or design. It's just purely for these initial state options, factoring in the construction stages with our load combinations. Okay, now that we are done defining the load combinations, again, considering the construction stages, we're finally ready to run an analysis. So before we run the analysis, what also is nice is that in my dropdown, I see all of those load combinations listed here. and I can actually cycle through them. So here's load combination number 1 with my dead load. Here's dead plus live. Here's my second construction stage, again, only with the dead load. And then I move on to the addition of that third story with the dead load consideration and then dead plus live. So again, the program's automatically combining all of these together. So under calculate, we go to the option to calculate, and I am going to select here only my valid load combinations to move over to the right-hand side. And when I click OK, the program is going to generate the FE mesh, and then new within RFEM 6 is this multi-core processor where we can solve load combinations simultaneously for a little bit quicker analysis here. So once the program is done solving for all of these load combinations, we're now presented with the static analysis results. So no design yet, just purely the analysis portion within RFEM itself. And we can see our results available to us in our navigator over here. For example, we're looking at load combination number 5, and we can view the global deformations of the structure. We also can take a look at the member internal forces, for example, the axial forces. Maybe we want to take a look at the bending moments here for our beam elements. So all of this is visible based on the various load combinations, again, that have factored in these stages. And of course, we also have our surface results where we can view the bending forces, MX, MY. We can view shear forces. This is obviously for my initial structure, stage number 1. So that is essentially the analysis with these construction stages, but I would like to show you how to incorporate also the design with these stages as well. So we can activate the design add-ons by selecting it within my drop-down box here down in the table. And we see here concrete design, and this is available because we activated the concrete design add-on within the base data at the beginning of the example. And you remember I stressed how important those design situations are because they are absolutely needed here when we move on to the design portion of our model. So we have here our first LRFD design situation. We're going to select here from our drop-down to relate this to the strength design for the ACI standard. Then I have my unfactored load combinations where I'm going to relate this to the serviceability design. Under my second tab, I would select all of the objects that I would like to design, and I can select all of my concrete members, except for, remember, I'm not going to design this rib element here, and maybe I want to design all 3 surfaces. So that's what's currently selected here. So I'm really ready to run my design as well, and I can choose this option here, show results. Now, I already have my internal forces from all of the load combinations. They're just simply brought into this add-on, and the equations from the ACI are applied. We consider the reinforcement to ultimately get our design ratio and required reinforcement for each one of these surfaces as well as our members. So once we are done doing the calculation, we can view here the design ratios on the surface, for example, and we're currently in table format. And notice at the bottom, we can view the design ratios by the construction stage. So here's construction stage number 1. Now we can view each one of these checks here for construction stage number 1. Notice we have a pretty high check here for our shear design. So we probably would want to address the shear design for this particular slab right around where this column element is framing in, but everything else for the most part looks okay. We can also view the design ratios by the surface itself, but we're still going to show you, you can see one of the columns here, which construction stage this is applicable for, as well as the load combination. And as we select any one of these options in table format, what's new within RFEM 6 is visiting the design check details. And the design check details are going to give us all of our variables in table format. And you can see over on the right-hand side here, all of our equations. And this one is rather complex, but if we scroll down to the bottom, we're ultimately going to show you how this design ratio is calculated step by step. We're going to give you the code references over here in the right-hand column. We also have additional code references in table format. So again, trying to be as transparent as possible where all of these calculations and code checks are coming from. Notice here we have our drop down where if we're looking at this particular location, mesh node number 2154, we can also select here any one of the other construction stages if we'd like, and the program will automatically update our calculations over here to show for this particular construction stage. Same concept here for our design ratios on our members as well. So we can see here design ratios by the construction stage. As we scroll through each one of these, we're going to see all of the checks here relevant to the ACI. We can also view, again, similar to the surfaces, the design check details. This one's a little bit more simplistic here for our member design, but the code equations are given, code references, and also new within RFEM 6 is we have added the interaction diagrams for these concrete columns. So now we see the 3D interaction diagram here. We can see exactly where we fall for this particular member. Now we can export this information to Microsoft Excel. So table format is nice. We also can view all of this information graphically over here on the left. So we see now we're no longer looking at the static analysis, but we're looking at the concrete design. And if we right click here to collapse these folders, we can turn on the design check of our members, for example. We can take a look at the strength limit states and the various checks shown here to graphically see, compare this to our color panel, what exactly is happening for these members graphically as well. So that will sum up just a quick introduction to incorporating the construction stages for the concrete design add-on, but to briefly touch on the steel design as well. Very similar workflow. You'll notice here under the steel design, we once again have our two design situations here, LRFD and ASD, and we will relate this to the strength limit state for our factor load combinations and serviceability limit state for our deflection checks for ASD design situation. Under the objects to design, this is where I could graphically select all four of these steel members. I click OK, and I can run the quick calculation here. Again, I already have the internal forces. It just brings them into the steel design, applies the AISC equations to ultimately get the design ratios. So we can view the design ratios by the construction stage itself, and we see construction stage 1. We shouldn't have much available there because remember those steel members didn't exist, but for construction stage 2 and 3, we see all of the relevant checks shown here. Now you can also utilize the filter options, and if I don't want to see every single chapter for each one of these members or construction stages, we can just filter to the max option. So now we see here what's actually controlling for each construction stage. And very similar to concrete design, we can visit our design check details, and we see here the code equations, the code references directly from the AISC 360, along with all of our information presented to us in table format. Okay, so this will sum up the example today where we have modeled the entire structure. We created those construction stages, not only for the model where we deactivated elements, activated other elements, but also the loading considerations where we need to factor in the construction stages as well to the load combinations and our design situations. And finally, we saw how we can incorporate those stages into the additional design add-ons. And keep in mind, it's not just specific to concrete and steel design, but we could incorporate this into our form finding add-on, aluminum design, timber design, and so on. So we'll go ahead and revisit the PowerPoint. I did just want to touch on a few future developments that we can expect with our construction stages analysis. So we recently added in RFEM 6, which we already had them in RFEM 5. It just took a little while to get them into our new version RFEM 6, but we now do have line, surface, and nodal releases, and these will eventually be added to the construction stages analysis consideration. Remember, all of those options to turn on or off for activation or deactivation, we'll add in these elements as well. I had already mentioned the stage analysis via load cases and results combinations utilizing linear superposition. So this will be extremely helpful for large models, many load combinations, rather than having to factor in these construction stages for each load combination. We can superimpose the results on the final structure to consider the stages. So this will be really helpful for just improved performance. We also will be adding what we call phased massive cross sections and surface thicknesses. So we'll be able to activate the element parts step by step. So for example, if we would like to increase the dimensions of a concrete column, for example, we'll be able to take into those phase activation here within the construction stages add-on. And finally, I already touched on this as well. It's a little bit more of a long-term development, but eventually we do plan to link the time-dependent analysis add-on for considerations such as creep and shrinkage within the construction stages as well. So this presentation was recorded today. It will be placed on our website at the same webpage that you had registered for the webinar itself. You'll also be able to download this example that I utilized today in the presentation, and feel free to open it in the free 90-day trial version of RFEM 6. That trial version is full capability. It comes with all add-ons, no limitations. And then after the 90 days, it turns into a demo version. If you have any questions about today's presentation or any of our products, feel free to contact us in our Philadelphia office with our contact information shown here at the bottom of the screen. Our phone number is 267-702-2815. And our email is info-us@delubal.com. And you'll find this information on our website as well. So we will have many more upcoming webinars presented about once a month. You can register at delubal.com under support and learning webinars. As most of you know, I will send out a reminder email about a week before these take place. So keep an eye out for that within the coming months. PDH certificates will automatically be emailed to all participants who are here for the full presentation. This is a requirement of the states that we are pre-approved providers, and in order to provide PDH, you must be here for the full 60-minute presentation. So this will not be automatic right after the webinar ends. It does take about a day or two, so just keep an eye out in your email for that PDH certificate. Now, if you watched with a colleague or you watched in a conference type setting and you yourself did not register for this webinar with your own name and your own email, you will need to request a PDH at the email address shown here, this info-us@delubal.com. Let us know who you watched it with. Again, if you yourself did not register, but you were here for the full presentation and want that PDH, send us that email. Again, info-us@delubal.com. And with that said, I want to thank everyone for attending today. And as always, we hope to see you at the next webinar. Thank you.